Welcome, everybody. Thanks for joining us today on Sneak Live. Today, I am very excited to have my friend Josh joining us. Josh Rosso, why don't you introduce yourself?
Hey everybody, my name's Josh. I work for a company called VMware. I came over from another company that got acquired by VMware called Heptio. I work on a project called Tanzu Community Edition, which is our open source community distribution of Tanzu, which I'm sure we'll talk a bit about today. So super psyched to be here with Eric. Eric and I worked together at VMware at one point too, by the way.
Yes, those were good times.
Yep.
Yeah, I actually met you before that. I interviewed at CoreOS way back, and you were
Oh,
one of the people
right.
that interviewed me, and I almost went there. Almost.
Yeah,
Sure,
yeah.
I did.
I forgot about the CoreOS days too. It's funny. There's a large contingency and trajectory of like humans who like were involved in the CoreOS era and then like went over to the Heptio era as well. So it's like I forget that there's like 3 links back now: VMware, Heptio, CoreOS.
It's like the planets of Docker and Kubernetes and everything else. The orbital patterns we all have, we're all kind of all around each other all the time. So
Exactly.
since
Yep.
now before we get into the the important stuff here, I just wanted to the important geek stuff. So since Josh is a climber and is used to the outdoors, and since this is a fireside chat, I figured I'd bring you a nice campfire so that we can be nice and cozy and have this conversation.
I like you a lot, Eric, but I wish I was there more than I wish I was here.
I do not blame you. I'm in the same boat, actually. I do like camping. It's pretty cool. I miss my son being young and being in the scouts and all that. So that's kind of distracting, though. So we'll take that off. So hey, so what we're here to talk about today is Tanzu Community Edition, and I worked with Josh at a time while this was kind of in its genesis and while he was getting started working on it. I was really excited to see you guys finally get it out the door. And I'm going to turn it over to you to kind of give us a level set. What is TCE? Why would I use it? How does it different from just another Kubernetes distribution? And you tell us about it.
Yeah, absolutely. So I'll just kind of talk a little bit and maybe see if I can share my screen here. That's a terminal window. Okay. Can you see my terminal window, Eric?
I can. There we go.
Okay, lovely. So at a high level, for those who just like enter the world of Tanzu, what we're trying to do with Tanzu is build a really robust Kubernetes distribution that I think uniquely rides the line between being an opinionated platform, but also one that's extremely pluggable and extensible. So another, piece of background from Eric and I, as we both worked in the field helping folks set up Kubernetes at scale. And one of the cruxes that a lot of groups hit is that getting Kubernetes is kind of trivial nowadays, especially with like managed services like EKS and all that jazz. But actually building something of value for developers on top of it is quite challenging. And there's a lot of really great things, like you look at the progression of like even like PCF, or I guess just Cloud Foundry in general, and how it had a really like opinionated approach to creating a developer experience. And when you worked well in that model, it was really compelling. But a lot of times you wanted some level of customization, the ability to swap certain components out and so on. And that's one of the things that we're really focused on doing with Tanzu Community Edition. So that's some of the framing, but let me just tell you, like, if you were to brew install Tanzu Community Edition or use your package manager, what would it look like? Well, the first thing that you essentially get is a CLI. And the Tanzu CLI is going to allow us to create clusters, manage clusters over time, install packages on clusters, which is probably something Eric and I will spend some time talking about today, and just do a bunch of different operations. This is like your entry point to Tanzu. Now, when you actually go in and create these clusters, what basically happens is you end up with, you kind of start off with a management cluster. And for those of you who are familiar with Cluster API in the upstream world of Kubernetes, this is all built on top of that foundation. We're heavily involved in Cluster API, contribute to it constantly, and this is largely an abstraction on top of it that brings a lot of features to the table. So right now I've got a cluster that's running inside of Amazon in this case. You can point your clusters at Amazon. We have a local provider to stand stuff up locally. You can do it in Azure. You can do it in vSphere. And as we stand up this cluster would then manage one or many workload clusters that we'd kind of put out there in the wild. Very similar to, again, what you'd see in Cluster API. Now, when you first stand up your management cluster, what you're going to get is the ability to basically set up the cluster using a UI. So if I do management cluster create UI, just to kind of show you, actually, let's see if I've got my, there we go. And I will share a different screen here, Eric. Sorry, I'm jumping around. Let's see if this works. I'll share my browser. Great, there you are. Okay, perfect. So you'll get a UI that looks something like this. This is actually the cluster that I had stood up. And you can kind of see all the logs and everything that it went through to bootstrap it, all the steps it did. When I first kind of got started with Community Edition, I landed on this page, and probably what I should have showed you all out of the gate. So when you first bootstrap your cluster, you get a UI that looks like this. It basically says, hey, where do you want to deploy? Do you want to just deploy something really simple and local? Do you want to put it in the cloud? And like I said, in my case, I did it in AWS. So I could go in and attach myself to my account, which then feeds all of the different settings inside of here. And what's kind of cool about this, again, those of you who play around in like upstream Kubernetes and Cluster API, is a lot of these options are really just like graphical ways to fill in the settings for Cluster API behind the scenes, which is pretty slick. Okay, so to kind of wrap the demo up here and go back to my terminal, once you get the cluster up, it's a Tanzu cluster, as we call it. And what I've got kind of going right here is you can see that I'm creating a workload cluster. So basically what happens is I go in and I say, give me this workload cluster. Here's some settings and properties about it. And it's talking to the management cluster to bootstrap the workload cluster. So all through this Tanzu CLI, again, I can see the details about my management cluster. And then I can also do things like ask for a list of my clusters. You can see in this case, I'm creating one hello that is currently being instantiated. Now, what's kind of interesting about this and relates to some of the security aspects is that in Tanzu, we treat everything as what we refer to as a package. And those of you coming from Linux land, like not a new concept, right? Like packages have always been the thing. You set up the kernel, and then most distributions are a set of packages that we bring on top of it. Everything from your window manager to your literal terminal is usually packaged in a package. So the idea here with the package plugin is that we can run a command like Tanzu package. And then when we set up Tanzu package, we can basically see what packages are available in the package repositories we have. So actually, I'll just do a package repository list real quick here. And it's going to retrieve the package repositories. They are namespace scoped. So I'm going to go ahead and pop back here. And I've got two package repositories set up in this cluster. So essentially, kind of like similar to like you'd use like Multiverse in Ubuntu or whatever your different package repos are, you can load these packages up in the clusters. And the idea is these packages become available as you stamp out your clusters. It does not mean they're installed though, right? It just means that they are available for use. So if I do Tanzu package available list, and to make this output less crazy, let's do something like this. We'll just get the first column. In this cluster, these are all the packages that I have available to me. Now, the package primitive is pretty interesting. So most of the packages that we produce, we actually use a tool called Carvel. Carvel. I keep getting yelled at because I'm pronouncing it like the ice cream, I guess.
I didn't. That's news. I just learned how to pronounce it.
Okay, cool. Welcome to the world of pronouncing things wrong, Eric. I do it all the time. So these are all packaged using something called Carvel. Now, what's really cool about this package primitive, though, is that you can actually wrap a variety of different things in this package model. Here's an example. Say you have a Helm chart that you've built out over the years. It deploys your super secure runtime CVE detector, privilege escalation detector thing on all the nodes, right? Whatever that is that you're using. That could all be in Helm, and you can still wrap it in this package primitive using Carvel and install it using these exact same commands. So really, we're trying to create a unified package management like experience on top of that. And then there's a whole ton of things that we can do here. Like, obviously, I could install one of these packages. Let's see if I have an install command set up in my history. Yeah, okay, we'll see if this works. So if I do kubectl get pods all right here, and we just set up a watch on this real quick. So watch that. Seems good. Make this a little bit smaller so that Eric can't read it. And then we'll do Tanzu package install. So this will actually go in and start installing the package. And by installing the package, it could be rendering a Helm chart. It could be rendering YTT as part of Carvel. It's like a templating language. And it's actually going in and installing this into the cluster. And what's great about this package model and leaning into it is similar to what you're used to with Helm charts and all different kinds of things. We can actually provide schemas to give people customizability in how they install something like Cert Manager. Because, you know, obviously it's neat that in this demo that I'm installing it, but in reality, you're probably thinking, well, Josh, like, how do I set all these important things I need to set and customize it? And there's a lot of like really cool ways that we can load up the schema, inject things, change things, move them around. So if I were to like take a step back and kind of summarize here, Community Edition and Tanzu in general, but Community Edition specifically, has really robust cluster lifecycle management, largely built on top of Cluster API. We again continue to put tons of effort into upstream Cluster API, independent of Tanzu, because we really believe in that model of declarative multi-cluster management. Once you have the cluster existent, we have this whole package management architecture where all the different building blocks, right? When you want to go from just like a container orchestrator, which is really all Kube is, and actually build higher level functionality on top of it, we can bring these packages in. Any set of them, you can bring your own, and then you can make these available, installable into clusters. And then the ideal state we want to get to, we're not here yet though, is have a really robust way to do multi-cluster package reconciliation and management, right? Like that's always been kind of the long-term thing that people are headed towards. You start off with a cluster in your org, and then all of a sudden you have 45 clusters in your org. And how do you provide consistency where it's appropriate, but also customization across these many different, I like to call them app platforms that you're stamping out, where Kubernetes is actually just, interestingly, another package in the grand scheme of the packages. It's just this kind of layer cake of packages on top of packages on top of packages. So, Eric, I probably will shut up there because that's a lot of info, but that's kind of like a very high level overview of what Tanzu Community Edition is.
No, that's great. So when you said Kubernetes is just another package, that makes it sound like it's like the package everything depends on. That just has it's just another dependency. Is that how I would look at it? Or
yeah, I think that's probably fair. Like, you know, we do treat some of the lower level components a little bit special for sure. Like those who have done a lot with Kube probably know a lot of times the kubelet, some of the other lower level components actually get baked into a machine image, right? So it breaks that model a little bit. But aside from the machine image, yeah, like once you have this dedicated package primitive all the way up the stack, you actually have a way to declaratively produce distributions. So not to get too heady with this, but if this makes sense, like if you agree on a consistent primitive, then you can actually use Tanzu to go in and actually build a completely custom distribution that is independent of Community Edition. You just need a descriptor file that says, here's the packages that are relevant. Those packages declare their dependency map with other packages. And then boom, you're standing up some edge version of Kubernetes with a weird version of the kubelet using X, Y, and Z security features. Like it's a really compelling vision, I think. We haven't realized it entirely yet, but it's a compelling vision for sure.
That's interesting. That tells me that the Kubernetes you're deploying is straight upstream Kubernetes. Then you're not doing any kind of massive modifications to it or forking it or anything like that. Is that
So
accurate?
in Community Edition, the fanciest thing we're doing is we're signing binaries right now.
That makes sense.
Yeah, but outside of that, you're totally right. And yeah, this is the power of this primitive is like we can point completely upstream, we can bring it down. Now in our product, because there's Tanzu Community Edition and then there's Tanzu standard edition. VMware really likes when people pay them money, of course, because it's very important as a company's health, right? If we keep this primitive consistent in downstream product, to your point, like say we do need to ship patches because Eric, you work at a really important bank, a CVE gets exposed in the kubelet and like, oh my gosh, like day zero, this is the biggest deal in the world. Well, with this package primitive and ability to use a declarative model to produce distros, we could in theory in product patch the thing before we get it upstream, deliver a new cut of the distro, and then boom, you run an update command and that package gets swapped out across all the clusters. So yeah, in summary, to answer your question, we are just using upstream stuff, but it also does give us the model in product to do more customizations if we ever needed to.
Okay.
Yeah.
Cool. So who do you see as who's the target user for this? Is it, but I'll let you answer the question.
Yeah. It is an okay way to learn Kubernetes. That's oftentimes when people see like Community Edition stuff, they're like, oh, like this is a good entry point to like learn Kube.
Yeah.
And not to down my own project or our own project, but like I actually don't. It's okay, but I don't think it's like the right entry point. So if there's people on this webcast that are or stream that are thinking about learning Kube, I don't know if Tanzu Community Edition is necessarily the right entry point. I actually think we're like a bit of a layer after that. Like once you sort of understand Kubernetes and you're starting to think, I have like problems at scale to start solving. I have like reproducibility and distribution problems that I need to start solving. I think that's the really interesting entry point of this open source project. Yeah.
Okay, cool. So you're not trying to replace kind.
No, we use kind actually.
Yeah.
Funny enough, one of our models, I'll just like, if you're okay with it, share my screen one more time super quick here. One of our deployment models for those who are like, I don't really want to like go bootstrap a bunch of heavyweight management cluster stuff and all these pieces. We have a model called standalone, which when you run it, it'll just locally on your machine go in and resolve all the different packages you want, package repositories. It'll let you customize these. And under the hood here, Eric, it's actually using kind. So, but to your point, I love Tanzu Community Edition. I think it has a really important niche. But like if someone came to me and they're like, Josh, I'm learning Kubernetes, like what should I do? I'd be like, oh yeah, like use upstream Kubernetes, like use kind, bootstrap stuff, learn about it. I think if you jumped right into Tanzu, if you're brand new to Kube, you'd be putting the cart before the horse a bit, so.
Very cool. So we have in chat, forgive me if I pronounce it wrong, but Kai Su, I think I might know who this is actually, but is asking, what's your favorite thing about Tanzu?
Yeah, I guess I'll be a bit of a broken record here. It is really this commitment to the package primitive. And I know it's like such a not sexy implementation detail, it's like, like it'd be cool if I was like, oh yeah, it scales like, blah, blah, blah. And it can scale and it can do all those cool things. But like, as somebody who's like in like the weeds of lower level architectures, I really think what we're doing here with this package primitive and being really consistent with building everything on top of it is going to allow us to do things that's pretty nuanced in the Kubernetes space. So that is by far my favorite thing.
To a lot of people that is sexy. So
yeah, exactly. Right.
I'm going to show my screen real quick. One of the things that struck me when you all put out TCE, that reminded me of something when I worked there. The documentation. I remember seeing the genesis of this, I guess. And what I'm interested in right now is this is on the Tanzu VMware Tanzu/community site.
Yep.
And it is what I call the layer cake diagram or whatever. I don't know what you guys call it, but it goes into all of the different packages. Now, maybe not all of them, but the heavy hitters, I guess.
Yeah.
Can you describe what are we looking at here? And then I'm going to get into a couple layers.
Yeah, sure thing. So to that point I made earlier, Kubernetes is becoming a less interesting part of the puzzle. And I mean that in a really good way. Like, we're now finding a really consistent, easy means to create our favorite container orchestrator, which for a lot of us is Kubernetes. Not that it's the only one, but it's a very popular one, right? And once Kubernetes is there and you look above the compute runtime layer, the nuance in where we're oftentimes headed is, how do we do the layers above it? Because at the end of the day, my experience has shown that if you just go to all your development teams and you're like, here's a Kubernetes, a lot of them will be like, oh, neat, a whole new thing I have to learn on top of shipping my own features. Because like, what we're really trying to do is we're trying to make developers more productive. We're trying to build platforms that make them more capable of doing their jobs.
Right.
And I actually think the layers above this are just like so key in choosing the things that help them. In my case, I call them our customers. Our customers as operations people do their jobs effectively. So the connectivity layer, of course, is just how do we make containers and pods intercommunicate? How do we get traffic from outside the cluster into the cluster? The actual services layer are what we'd call like platform services. So things like oppa that actually can protect new objects we're looking to create, the cluster from new objects we're trying to create. Pinniped that's going to allow us to hook into OIDC and provide auth, the layer that does backups. Build and deploy, as again, like as you're getting a layer higher, you're getting more into the dev concerns, right? Build and deploy things like Knative, where developers can set up serverless containers so that you don't have to constantly run and waste compute on a container based on inbound events. You can spin up that container, you can do that work, so on and so forth. Kubeapps is an app catalog. Kpack lets us build container images, and then at the highest level, observability. The ability to, again, use our package model to instantiate Prometheus instances, Grafana instances, and perhaps fill your whole cluster with Fluent bits so that you can be forwarding logs, getting observability on applications that are running, and so on.
Cool. So, as you're talking through it, I'm thinking of questions. In the connectivity layer, I noticed you've got Multis in there.
Yeah.
That's actually interesting to me because in my time consulting around Kubernetes, Multis was always kind of seen as a science project. Is it gotten mature enough? Are you finding that it's widely used now? Because it is interesting to see multi-CNI coming in here.
Yeah, totally. It's always funny with Kubernetes because what we consider to be like bleeding edge, or what a lot of people would consider to be like very new and bleeding edge, we're like, it's production ready. Just freaking use it. But to answer your question about Multis, it is. It rocks. It gets used especially in telcos where they need to hook pods up to multiple networks. And I can't like name drop names for a variety of reasons, but I can tell you with certainty that people doing like SRIV stuff, SRIVO, am I saying that acronym right? Anyways, who are doing that kind of stuff and then hooking into like a more standard container network like Calico or Entrea are totally using Multis. So, the Multis is another example of a package. The package gets installed in the cluster, and then other CNI packages can get installed in, and Multis can wire them up. And it is definitely a very, very popular way, especially in the telco space, to do multi-CNI or I should say just multi-network pod stuff.
So let me tease that out a little bit. So where I remember hearing about Multis the first time was years ago. It was still pretty raw. There was a financial I was at that needed to use something that supported multicast, and they wanted to use Weave because it was at the time I think it was the only CNI that really where it was a top level citizen. But they wanted Calico for its network policy, but they liked Weave for that one aspect, and they wanted it all in the same cluster. If I wanted to, I don't see, for instance, Weave on this diagram. If I wanted to add Weave as a CNI onto my TCE or any Tanzu really cluster, how hard would that be to add a package, or how would I go about doing that at a high level? You don't need to
Yeah, no, of course. I think we're talking about like, there's obviously an on-ramp of understanding the package model and how it works and the tools involved in it. But once you've got that down, I mean, we're talking about like, you could take a Helm chart for Weave and wrap it in a package in 30 seconds and make it available in your cluster. Yeah.
That's pretty cool.
Yeah, absolutely. And you know, I should say, to your point, like we definitely have like, there's like things I could circle on here that are probably like the official community edition vanilla distro, like Entrea would be the thing I'd circle in the container networking box, right? But we want to just continue expanding these things. Like, this isn't like a VMware only lets these things in, or it's like gated. We very much want there to be a plethora of CNIs available inside of our distribution.
Well, it makes sense. On the initial release, the things that are in here are going to be things that where the contributors to those projects are involved in this. So that totally makes sense. I like that you have Contour in there for Ingress. That's my favorite right now.
Yep.
Very cool. Let's move up the layers then. And I am curious in the services. Now, here's where we're, being Sneak, where I'm kind of security minded on a lot of things. I see oppa. I'm assuming that's with Gatekeeper.
Got it.
Yep. Is there any other integration with oppa that you guys are looking at or thought about, as far as maybe providing it to applications for their microservice authentication between things, or anything like that, where that would be like a blurring of the lines between this service and the application, higher level?
Yeah, no, absolutely. I mean, it's a really interesting question that I actually don't know like what the right approach this would be. So let's just talk about it. So today oppa is pretty vanilla. It's going to instantiate oppa, set up Gatekeeper, and then at that point you could just start injecting your policy templates through whatever that CRD abstraction is. I can't remember what they call it exactly. So it's very much tuned to put in and then do kind of like the ops level protection. That's going to give you the typical like Gatekeeper-esque experience. Now, on the app level and hooking it in, I think that it would be a really interesting question. Like, when you run oppa, and I don't know if you know this offhand, Eric, but you're running oppa in your cluster, and it's hooked up through the Kube API server as an admission controller, and it's validating new objects that you'd want to create and determining whether you have the rights to create them, or authorization, I should say.
Sure.
I would guess if you're probably doing it from an app level, you'd want to run separate instances of oppa, right? Because you wouldn't. I don't think
you sidecar on your app.
Perfect. Okay, cool. Oh, a sidecar. Okay, got it. So yeah, if you were injecting it as a sidecar, I think a really interesting thing that you'd have to consider then is like, when the oppa, so the oppa sidecar, right? It's going through and it's like, it's able to be communicated with by, I'm guessing, other apps that would call that app sidecar. Is that kind of how the architecture generally works?
I'm getting into theoretical here. I haven't actually implemented it, so I believe
cool. Yeah. So in summary, like I'll answer your question succinctly. The current oppa package is very much it's Gatekeeper oriented. It will install inside of the cluster, and it will be wired up through admission control for you to put policy templates in. Now, if you're a developer who's trying to put it in as a sidecar to your app, you could very easily wrap your whole application in this package model. And what's cool about the package model and this whole schema idea is that it's really, really easy, kind of similar to Helm and other things, to provide values or flags that determine how the package will be unpacked and ran. So what I'm getting at here is, like, if you wanted your package to be installed in a bunch of like dev clusters and stuff like that without the oppa sidecar, let's say, because you just want to like run the app, test it out, whatever. The package could be, a package install command could be run with a little, command or flag value that says like no oppa, whatever, no auth z. And then you could then run it in production with that flag off, which could then instantiate the oppa package, or sorry, the oppa sidecar in the template of the manifest. So yeah, there's a lot of ways that you could do it. It's a really interesting thing. I will say the reason this question is so interesting to us is like, we're still a bit like on the operations side of the stack. Like this primitive, again, like it's a really interesting idea of what does it mean to app developers? What does it mean to, the customers themselves? Should they be interacting with it, or should it be more of an implementation detail? And I think the jury's still out on that one.
Okay,
So
let me tease it out in another direction then. So let's say at my company, all clusters that are created, we want to have a standard set of Rego rules applied by a gatekeeper OPA.
totally.
Um, how do I leverage that so that when Eric, the developer on Team X, spins up a cluster, that I automatically get the right version of those policies in that package?
Yeah, absolutely. So like I think what's so sweet about this is you'd have the OPA package still get reconciled and installed when the cluster gets stood up. Then I would, instead of trying to pollute the existing OPA package, I would create a package of those policies, because at the end of the day, when the package is unbundled, it's this OCI asset with a bunch of manifests in it that potentially get rendered. So I would have the company's default set of policies in that package, and you would hook that into cluster creation so that when the cluster is created, that package is installed. So now the OPA package gets installed, and then the policies get unpacked in every single cluster. And now, similar to what we've seen with like container images and immutable machine images, Eric's like policy bundle for your company, it's now semantically versioned in these immutable packages. So when the policy changes, you re-up the package, it gets pushed to the OCI registry, and now you have this, again, these sets of completely immutable package definitions that are all bundled together.
Cool. So one of the things that I'm also fresh on my mind. I'm finishing our book club is finishing your book that you and the other guys there wrote.
Yep.
And one of the things I'm thinking about is multi-tenancy. And
Yeah.
I know that in Community Edition, that's probably a little bit outside of the normal scope of what most people running Community Edition would be doing. But how do you deal with, oh gosh, what am I trying? I'm trying to verbalize my question. Let's say you wanted to have a set of network policies
Yeah.
that every, let me back up. Let me do a different question. Let's say namespace creation rules.
Right.
How would I, if I want to have a self-service namespace creation, because that's how I'm going to do multi-tenancy in my dev org, how might I, what package would I need to do that in, or how would I set that up here? Or is that just something you do after you've stood up your cluster and it's not really part of that?
Yeah. This is a really interesting question because there's so many ways to approach this. And I love the use case you said, because can't think of an organization that I've been to that didn't say, hey, we want some way to like instantiate namespaces with default resource quotas and limits and network
Right.
policy and all these things associated with them, right? So here's how I would do it. And I'm not saying this is the right way, it's just how I would do it. I have not been keeping track of like the operator and controller space for this kind of thing, but I've built at this point probably like 1,000,000,001 different namespace creator operators. I really think that it's almost not even an operator. It's more of just like a pure controller, right?
Mhm,
But like
mhm.
the operator controller model, I think makes so much sense for this use case. So I would go through and I'd be like, okay, cool. You want a way to onboard teams with a namespace. So what fields, Eric, do we want? And you'd be like, okay, Josh, well, I want there to be the name of the namespace. I want people to say how much memory they want to allocate to that namespace. And then I want, or maybe that's all you want. You want memory and the name. It's really simple.
Sure.
And we'd be
Okay.
like, okay, sweet. Let's set up a schema for that. We'd set up a little YAML file. It'd say name and that. And then we would build, unless there's something out there in the open now, we'd probably build a little operator or controller that looks at that CRD for that YAML file that we just created. And when they get created, it goes in and it translates the specific things that the developer cares about into the underlying Kubernetes resources. So it's kind of like this translation of like, the users only have to specify two things, name and memory limit. The controller sees that and then instantiates the namespace object, the resource quota object, the default network policies, the on and on and on, RBAC, on and on and on. And all that's largely abstracted. So once you and I build that together or find
Mhm.
some open source tools that can do that for us,
Right.
we've now got the vision for our kind of developer on-ramp. Then the package primitive comes in. So we would take that work we did, we'd put it in one of these little packages, right? And then when we install clusters, we would either, after the cluster gets bootstrapped or when the cluster is bootstrapped, say that we want this package installed in the cluster. And then that operator would just look around and instantiate namespaces whenever it sees that CRD get put into the cluster.
So as we're talking about these packages, it's harkening back to something from a couple years ago, maybe 3 years ago. There's a CNCF project that Pivotal, before the merger with VMware, Docker, Microsoft, and I know there's another partner in there. I can't think of who it is. We're working on, might be VMware actually, on cloud native build packs.
Yes.
And is there relation between Carvel, I pronounced it right, Carvel,
You got it.
and
I think
that,
you've got
or
it
is that
right.
a different project completely?
Yeah. So cloud native build packs are super interesting. Let's like here this I'm gonna try to share my screen again. Let's try to like break down the layer cake real quick. Otherwise I'll just be saying a bunch of acronyms. Okay, do that. Share your screen, Josh. Share screen. See if I can get this Miro screen shared. Sweet. Okay, cool. All right. So there's like multiple layers here that we're primarily worried about. Now, the one thing that we are focused on is this idea of like an OCI image or an OCI bundle. Now, this, for those not as familiar with OCI, this is basically the standard for your container images, which are basically file systems that we tar up and we put in this OCI format, and we put on, you know, everything from Docker Hub to Quay to whatever people are using nowadays. So there's the OCI image itself. And then on top of the OCI image, there is, well, I guess the OCI is a format. So let's just keep that here. Now, what ends up in an OCI bundle could be anything from like a container image, right? Which is really just a tarred file system in a lot of ways. It's a little more complex than that, but that's kind of what it looks like. But at the same time, like, it doesn't have to be a tarred file system. It can just be a set of files, right? It could be a bunch of JPEGs, which would be a really weird thing to do, but not impossible. But more commonly, it could be like a set of YAML files, and we can put both of these things into this kind of like OCI format. So our packages, and the reason that I want to bring up this diagram is what constitutes a package is a bunch of primitives we use with this thing called Carvel. But at the end of the day, when we push them up, it's just this OCI format that goes into a registry. Now, Eric's question initially was this idea of cloud native build packs, and we're still invested in cloud native build packs. We still use them. The idea of build packs, just in general, is to actually provide a bit of an abstraction in the art of developing containers. Because like think about today, Eric, if we created if we wanted to create one of these OCI images representing one of our containers. So what you and I would probably do, because we've been in this stuff forever, is we'd create a Docker file, and it would have a bunch of information. But when you think about like, what are the things in a Docker file that Eric needs to know to be successful? Well, first off, you need to know what your base image is. And this might sound really trivial, but it's actually wicked complex. And if you choose a bad base image, you expose yourself to CVEs and blah, blah, blah. And then you have to run a bunch of commands, right? And then you potentially have to figure out how to do multi-stage Docker builds, because you need to remove the build tools for the runtime image, right? And if some of these words and boxes don't mean anything to you, like, that's totally normal, because these are like really in-depth things that you kind of have to worry about when you're building one of these Docker files. So the premise of build packs is that, can we take these decision points and can we codify them such that as a Java developer or as a Go developer, I can just write my code, run my build pack, and it will make really good informed decisions to produce the end state image. So where I'm going with this, and I'm almost done. Sorry, this got really wordy. The idea with this is that I would basically take my Java code, right? I would run it through a build pack. So Java ultra good build pack. And then by running it through the build pack, I would get a secure, minimal, good image for my Java code. And this, again, would be a OCI image. Now, what we then do to bring this full circle and to maybe answer what you were actually asking about, Eric, they are different things, the build packs and the Carvel packages I've been talking about. These are the container images that we produce. We then take all the YAML files, right? So let's just call these the manifests, more or less. And these could be templated or not. The manifests that basically point to this OCI asset. And we take this a step further by fully bundling all of these and creating one of these packages that we've been talking about, right? And this ends up being an OCI asset. So a way to think about this is, at the end of the day, this is what hits your cluster. Inside of this package are a bunch of manifests, and these manifests can reference one or many images. Now, how you, Eric, produce that image, be it from cloud native build packs or from Docker files, doesn't really matter to the package. It's more of an implementation detail. Does that sort of make sense?
It does. And
Sweet.
you are spurring another question in my mind. So
Yep.
for anyone who attended KubeCon this past was it a month ago? Month and a half ago? It's been a while now. They could have renamed that conference Secure Supply Chain Con, right?
Yeah.
How do you have you, I mean, two-part question. Have you and the team been looking at tools like SigStore, the stuff that the guys at ChainGuard are doing, or any of the SBOM related things as it relates to this package hierarchy and signing all of this and that whole secure supply chain concern? Have you been looking at that? And if so, what are your thoughts as far as how best to produce SBOMs from this process?
Yeah.
It's kind of a tangential thing to TCE, but it's such a huge deal in cloud native right now that it comes up in every conversation.
Yeah, it's weird. It's like we're finally starting to take security seriously. So I love this question because okay, so in Tanzu Community Edition today, just full disclosure for anybody who uses it, if you're trying to set up a secure supply chain in it, there will be some legwork and a lot of glue you got to figure out. No question. We're not completely there yet. But why I'm really psyched about this being important and us starting to take it seriously is that if we think about all of these different things, okay, and I'm just going to like name drop some projects that may or may not even be relevant to each other, but let's pretend that like cloud native build packs are in there because like then you can provide known secure build packs. We've got SigStore to some degree hanging out. We've got like in oppa linter. I don't know if you remember the project, Eric. There's a really popular like way to run oppa policies on command line to lint stuff. I'm blanking on the name, but anyways, yeah. And then you've got like image detector thingy. All the things that like
like Sneak.
Sneak, yes, a perfect example.
Got to throw it in the logos on the screen.
Hey, it's right here, Sneak. So you've got Sneak in here, very important piece of software, and you've got all these other things going on too. Now, here's kind of where I'm going with this. That's pretty compelling. Today you could make all these packages, you could mix and match Helm and Carvel and all these things and then glue them together. But what's sweet about this primitive and where we're headed with it is I think that a lot of folks are just going to want to come to Tanzu Community Edition and be like, hey, it's so cool that you give me all these Lego blocks, but can you just give me like an example of what a secure supply chain might look like? Mm-hmm. Now, each one of these packages, we have the ability to wrap into a package called, the secure supply chain package, let's call it, in which this package basically is a container, or a container would be a really bad word to use there. It's a holder, a referencer of the dependencies of the many other packages that make up your secure supply chain. And it puts the glue in place. And by the way, this is not an architecture diagram. I'm just drawing arrows that actually hooks together all the thingies in the different stages. So you think about this, if we can get these primitives in here, if we can get things like Sneak in there and then make them available in Tanzu Community Edition, then we can wrap this higher order secure supply chain package. And then the user experience around this becomes somebody basically running the command Tanzu package install secure supply. And then that basically looks up this package, takes any configuration you need, and then it installs it into a given cluster. So my answer to Eric's question, just to make sure I'm clear, is We don't have a great answer out of the box for this today because we've been so focused on this lower level primitive. But we do have something where we can build these things together. And then not only that, this is where I get like super psyched. Eric can say, I hate oppa, which is what Eric always says,
I
right?
would never say that.
I'm totally just kidding. Eric does not hate oppa. But Eric can swap oppa out with Eric's admission controller thingy, right?
Yeah.
That he built that's so much better than oppa, right? Now he's got this really pluggable way to build his own secure supply chain package. And that is a really, really compelling future that we're psyched about.
Very cool. I'm not going to pull the block layer cake back up again, but the one thing I didn't see in there, unless I'm just missing it, was any CI/CD tooling. Is Tecton kind of the thing now, or what? Or do you just not have an opinionated package for that?
Yeah, you'll see one show up soon. It's just a gap right now.
Okay.
We like Tecton a lot, so.
Yep. Well, we have about 10 minutes left, a little bit more than 10 minutes. Why don't we go to, what do you see coming in the future? What's coming next that you can tell us, obviously? Whether it's security related or not, what should we watch for? What are you excited about in the future?
Yeah. Let me give an answer that's not security related so that I can try to think of a security related one. So one thing I'm really excited about are different ways to utilize the Kubernetes API without bringing the whole of Kubernetes around with it. I think this is super, super interesting. Like if we all take a step back for a moment, when you deploy Kubernetes, you get an API server, and then you get basically etcd, controller manager, a scheduler, specific kubelets, on and on and on. And that's great. But I think the declarative API and the reconciliation, whatever the word would be, the reconciliation nature of Kubernetes is something that's like really, really nuanced and great. But then you take a lot of the stuff that comes with, standard Kubernetes and you try to apply it to things like Edge, or you try to apply it to just alternative use cases. Maybe it's like even like a workstation use case. I don't know. And I think if we really kind of peel back some of the layers and do some work upstream to kind of decouple how some of these things are wired together, there might be a model where we can build things like a really minimal, fully embedded API server that like there is no standard controller manager, scheduler, and all this stuff. You build like a very specific controller that looks at the API server and like, I don't know, maybe it like talks to systemd and starts processes to satisfy what the API server is declaring it wants. Like this is all like theoretical and crazy. But a concrete example of a group that I think is doing this is I think it's mostly led by Red Hat. There's a project called KCP. And KCP is a way to really minimally stand up a Kubernetes API server. etcd is fully embedded in it and so on. And then you bring your own controllers to that can reconcile against it. So I'm really stoked about that premise. We're probably really far out and it's maybe a little bit like science fairy at this point, but I think it has a future. Then as far as security goes inside of Kubernetes, I guess I'm just going to take the really easy route here and just say that like, I'm really looking for us to have more consistent standards around how we do security. Like it's this really interesting crux of like, we want the way that we deploy Kubernetes to be extremely pluggable. And that's a way that Kubernetes really shines. But my experience so far has shown that like without a really good set of defaults that we can advise people to use, it means a lot of people end up with pretty insecure clusters.
Right.
And I don't have an answer for us here, Eric, but like finding a balance there where it's like not that hard to figure out some sensible security measures. Like okay, here's a concrete example. Do you remember PSPs, right?
Mhm.
PSPs were great back in the day. But they impacted the UX of how you used Kubernetes. They were really conceptually hard to understand. They
As
had,
somebody who had to troubleshoot them with you,
yeah,
I remember these conversations.
yeah. So many times you'll be like, why is the PSP
Yeah.
not catching this? And why is the PSP freaking out about this? So like, again, I'm not trying to poo-poo on PSPs
No,
here,
not at all. Yeah.
but more so just like finding a way to provide that type of functionality, be it through Gatekeeper, be it through other tools, be it through things Sneak does, and having sensible defaults that are extendable.
Yeah.
That's a thing that I'd love to see the security field help us, like myself, these very naive operators and developers kind of get bootstrapped with. So.
Yeah, well, I could see. I mean, I know SIG Security's been talking a lot about the PSP 2.0, which is Pod
Yeah.
Security Admission, and I could see that being something that would be a package that would just get applied on top of a Kubernetes 1.23 or better distribution, right?
100%.
Um, yeah, another thing I could see that would be kind of cool would be if the OPA Gatekeeper you install had what aspects of the CIS Kubernetes benchmarks it could oversee would automatic if you could ship it with that. It reminds me of a lot of vendor based Kubernetes distributions, including some of the ones that you've worked on, have shipped. And one of the ones I used to work on used to say, we're secure out the door, right? We're secure from day one.
Exactly.
Because they've turned all the knobs for you and they're set up an opinionated security solution. They made secrets are encrypted for you all at rest. All those kinds of things are already done for you. It'd be kind of cool if there was a TCE mode to say turn security to 11 and make it not work for anybody until they start undoing some things.
Yep.
Zero trust network policy automatically deployed, things like that.
Yeah, I would love us to get to that point. And it just kind of comes back to this narrative of like, if we can declaratively say, remember, a package isn't just software, it can be configuration and
Right.
settings and defaults, right? If we can get to this model where everything is in this consistent primitive, then we can link up. Talking about BOMs, bill of materials, we can declaratively make pointers to all the aspects based on what Eric wants. Like, here's the thing, like when you turn all the security settings on, if you're just playing around and trying to deploy pods, you're probably gonna have a bad time because I bet all your pods you're playing around with are insecure or using host networking or doing weird things, right? It's just how it works, right?
Mine,
But
everyone
yeah,
else.
of course. But like, it's something that you should be able to turn on, just like you said. You should be able to flip that switch and it should bring opinions into the cluster, which would be a great state to get to.
Well, one box we didn't talk about while we've got a few minutes left. I see Sonobuoy in there.
Mhm.
And how do you see that being used by the average TCE user? I mean, because that's gonna, as I remember Sonobuoy, I never got to actually use it when I was working with you guys, but it's a compliance checker, right? It looks at the cluster at the cluster configuration point. It's not an application compliance. It's more of a, or am I wrong? I mean, what is it? What all does it check, and how does it play into TCE?
Yeah, so Sonobuoy's got an interesting legacy. It's something that we developed at Heptio and have brought into the mix at VMware.
Right.
Its legacy is to run Kubernetes conformance tests. That's its most popular use case. And Kubernetes conformance tests, if you all aren't aware or some aren't aware, when you build a Kubernetes distribution, you run these conformance tests, and it basically gives a thumbs up or thumbs down as to whether your distribution or whatever is operating in the way we expect the interface of Kubernetes to operate so that we can call it a Kubernetes distribution or not. So that is its primary use case. And today, if you deploy Sonobuoy, that's one thing you can do. Like the nice thing about conformance tests is while they're important for vendors like VMware, they also can be like kind of a cool sanity check for your cluster. Like it'll like spin up pods and make sure they're working and blah, blah, blah. Now, here's the thing about Sonobuoy, and I'll fully admit, like I just feel like Sonobuoy is a really great tool with great potential, and we just haven't like executed on that potential yet. And that is that the tests are arbitrary and pluggable. So this is basically an in-cluster daemon that you could write any set of tests for.
Right.
It could just be like, a test that runs on Wednesdays that figures out, has there been drift in those namespaces that we were just talking about creating earlier, right? Like did policies get mixed up, or, any use case you can imagine. If you need a test case to run in cluster, and give you results. Sonobuoy is a great tool for that. But again, to be transparent, today its primary use case is mostly running those conformance tests.
Yeah, I think the places I remember seeing it used that I was kind of around was sanity testing after an upgrade or a migration to a new cluster or something like that.
Exactly.
So
yeah, those are still, for what it's worth, the most common use cases. The needle hasn't moved a whole lot, but if we at VMware can get the community to rally behind it, I could see it being really compelling, at least for operators to run a variety of sanity checks inside of their clusters. So.
Okay, well, we're coming up on the top of the hour, so I think we're going to wrap. Anything else you want to say before we close it out?
We are on GitHub, and we are also at Tanzu Community Edition.io if you want to check out our docs. We have a public Slack channel as well. Check it out. And if you happen to not like it, let us know. And if you happen to like it, feel free to let us know too. We love feedback. We love engaging with the community. And yeah, just thanks again, Eric, for bringing me on today. It's obviously great to see you again, and just great to talk about Kubernetes stuff and cloud native.
Okay, well, I'm gonna bring our campfire back in, and we can warm ourselves around the circle. Thanks a lot, Josh. It was great to get to talk to you again for more than just 3 seconds.
Yeah.
And chat on TGIK or something. Thanks for tell your team great work, and thanks again, everybody. Have a great afternoon, and if we don't see you again before, have great holidays and New Year, and see you again soon.
Later, y'all.